Phosphonate drop test using pH paper featuring Taylor's K-1583. Who should use this kit? Taylor makes 2 drop test kits for water treaters monitoring phosphonate treatments in boilers and cooling towers. Phosphonates, also known as organophosphates, prevent scale, such as calcium carbonate and calcium sulfate. Some varieties can provide protection against corrosion. There are several types of phosphonates, the most common being HEDP, ATMP, and PBTC. They have varying degrees of scale and corrosion inhibition capabilities. They also differ in their ability to resist oxidizers and high temperatures. Our K-1583 is appropriate for use with 6 treatment types, including HEDP, ATMP, and DTPMP. For PBTC and HPA phosphonates, use Taylor's K-1584 test kit. These 2 drop tests rely on the thorium nitrate method, using different indicators for the titration. The instructions in the kits include conversion factors for the different types of phosphonate. Both tests require adjusting the pH of the sample. This step distinguishes our method and is important because the correct endpoint will not be reached unless the sample pH is adjusted to the specified range. In this video, we demonstrate the proper way to perform a drop test for phosphonate using the K-1583. The endpoint of the titration will be easy to recognize as the color of the sample will change from yellow to a purplish pink. The results are read in parts per million of phosphonate product after the proper conversion factor is applied to the number of drops used to reach the endpoint. Note: the K-1583 contains a masking agent to eliminate interference from fluoride. Iron can cause negative interference at a level greater than 5 ppm. Orthophosphate and polyphosphate can cause positive interference at all levels. Before beginning this or any other Taylor test, it is important to read the instructions through to the end. Familiarizing yourself with all the steps is particularly important if the test is new to you, or if the kit is newly purchased, as sometimes our procedures change. It is important that the cooling or boiler water sample be collected shortly before the test is to be performed. Boiler water samples should be cooled to 80 to 90 degrees Fahrenheit. No filtering of the sample is required. To perform a drop test for HEDP phosphonate, rinse and fill the 25 ml sample tube to the 25 ml mark with the water to be tested. Add 1 drop of reagent 697, thiosulfate, to neutralize any chlorine in the water. Next, add 10 drops of reagent 805, fluoride masking agent, to neutralize any fluoride in the water. If this interference is not removed, a false high phosphonate reading will result. Finally, add 1 dipperful of reagent 802P xylenol orange indicator powder. Swirl to mix thoroughly. Before beginning the phosphonate titration, it is necessary to adjust the pH of the sample to a value between 2.6 and 3.0. To adjust the pH, add 1 drop of reagent 686P sulfuric acid to the sample. Swirl to mix. Dip the part number 9315 test paper into the sample, in the direction of the arrow, being certain all color zones are immersed. Remove the strip after 3 seconds. Match the color zone, the unnumbered square between 2.7 and 3.0 on the color standard, with the color scale. Read the printed pH value. If necessary, continue adding reagent 686P sulfuric acid dropwise, swirling and checking the pH with a new test paper after each drop until a pH between 2.6 and 3.0 is obtained. The sample should be yellow. However, note the yellow color by itself does not necessarily mean you are at the correct pH level. We suggest recording the number of drops of sulfuric acid used, so on return visits you can save time and test paper by having an idea of how many drops of acid to start with. Once the sample is at the proper pH, it is ready to be titrated. Holding the bottle vertically, add the reagent 803 phosphonate titrating solution dropwise, swirling and counting after each drop until the color changes from a yellow to a purplish pink. The color change is best seen by looking down through the sample. Record the number of drops used to reach the endpoint. Run the same test again using local tap water. This will serve as your blank test. The blank serves to determine the demand the indicator itself has for the titrant. The blank usually requires only 2 drops of reagent 803 phosphonate titrating solution to reach the endpoint. Subtract the number of drops used to reach the endpoint with the blank from the number of drops recorded in the previous test. Multiply the resulting number by the appropriate conversion factor, in this case for HEDP, and record your result in parts per million. The next segment of this video demonstrates what happens if the fluoride masking agent is not added before performing the titration. We will use the same sample water as the previous test. Recall it took 9 drops to reach the endpoint. Here, we add 1 drop of reagent 697 thiosulfate. But the reagent 805 fluoride masking agent is not being added, so the fluoride deliberately has not been neutralized. Next, we add 1 dipperful of reagent 802P xylenol orange indicator powder. Swirl to mix. The next step is to adjust the pH of the sample to a value between 2.6 and 3.0. This previously took 2 drops of reagent 686P sulfuric acid. We will add 1 drop less to start, then continue with the pH adjustment step, which will help expedite our test procedure. Swirl to mix. We'll dip the part number 9315 test paper into the sample in the direction of the arrow, being certain all color zones are immersed. After 3 seconds, let's match the color zone, the unnumbered square between 2.7 and 3.0 on the color standard, with the color scale. Read the printed pH value. Continue adding reagent 686P sulfuric acid dropwise, swirling and checking the pH with a new test paper after each drop until a pH between 2.6 and 3.0 is obtained. The number of drops needed should be the same as in the first test. Our sample is yellow now, although we know the yellow color by itself does not ensure we are at the correct pH level. Holding the bottle vertically, we add the reagent 803 phosphonate titrating solution dropwise, swirling and counting after each drop until the color changes from yellow to a purplish pink. This comparison test that omitted fluoride masking agent required 19 drops of phosphonate titrating solution, while the test using the proper procedure required only 9 drops. In the absence of the fluoride masking agent, we're led to believe the sample contains much more phosphonate than is actually the case. The lesson? Not adding fluoride masking agent will likely cause the water treater to underdose the phosphonate treatment. After performing the desired test, remember to rinse all glassware so that the sample cell does not become discolored. The phosphonate test method in the standalone K-1583 is also employed in 4 boiler cooling combination kits. the K-1680, K-1690, K-1692, and K-9105. Taylor's knowledgeable customer service representatives are available to provide technical assistance about our products. Call 800-TEST-KIT